Extreme values, graphically. What does the behavior of this curve at x equals a, x equals b, and x equals c have in common? So here, here, and here. We'll see on the next slide. They all have horizontal tangents, so their slope at those points is 0. So here's a horizontal tangent, and horizontal tangent. You can see the slope of these lines is 0. And what's different about the curve at each x value? There's a maximum at x equals a, here. There's a minimum at x equals c, here. And x equals b is neither a maximum or a minimum. Critical values. Observe here that at x equals -1 and at x equals 2, the function contains a cusp. At those points, the slope is undefined, so it's not 0. However, these points are considered maximums and minimums. A critical value, or critical point, is a point on the domain of a function at which the slope is 0 or undefined. When asked to find max and mins, only critical values are considered, but this does not mean that all critical values are maximums or minimums of the function. Looking specifically at x equals a and x equals c, we see the slope is 0, here and here. What do you notice about the slope on either side of a and c? Here. In both cases, the slope changes from positive to negative, or vice versa. Here, we see the slope goes from negative past this minimum here, and then becomes positive again. Due to this, a maximum will occur when the slope changes from positive to 0 to negative, like it does here, and a minimum will occur when the slope changes from negative to 0 to positive. How does the curve behave around x equals b, here? Well, the slope before and after x equals b is the same. In this case, it's negative on both sides, so no maximum or minimum will occur when there's no change. Definitions. Maximum, a high point on any interval relative to points around it. At this point, the slope changes from positive to negative, and the function changes from increasing to decreasing. Minimum, a low point on any interval relative to points around it. At this point, the slope changes from negative to positive, and the function changes from decreasing to increasing. As we saw in the first graph at x equals b, there was a slope of 0, a critical value. However, it was not a max or a min. The same can be seen in these two graphs. Both have a critical value at x equals 0, but only one has a minimum. Which one? Well, this one is a minimum because we see the slope goes from negative to 0 to positive, and it's a low point relative to the points around it. Here, we have a slope that's positive, then goes to 0, and then it's still positive. So this is not a max or a min. Identify/label each of the following with maximum or minimum. What do you notice about what's occurring at the star? Here. At the star, the slope is 0, but it's neither a maximum or a minimum, because you can see the slope here is positive, and then it continues to be positive after it levels out. At x equals b, here, the slope is undefined because this is a cusp, but it's still a maximum.